You type words into a box and magic happens. But what if I told you that magic is just math, code, and a whole lot of patience? Every single day, billions of people type words into a search box and expect magic to happen. You type a query, press enter, and suddenly relevant results appear. It feels like sorcery. But that magic is really just algorithms, data structures, and a lot of careful engineering. What if you could look under the hood and see exactly how it all works? That is exactly what Rajdalak set out to do with a side project called Searchcraft. Instead of using Elasticsearch or Lucene and treating them like black boxes, he decided to build a search engine from first principles. No shortcuts, no magic, just Python, one component at a time. Searchcraft is a search engine built entirely from scratch in Python. The author describes it as a learning project, not a competition with mature tools like Elasticsearch or Lucene. Those projects are incredible, but they are also so mature that you can use them for years without truly understanding what happens underneath. Searchcraft exists to change that. The goal is simple. Implement each core component of a search engine yourself, document the journey, and see how far you can get. The project lives on GitHub under the repository name Rajdalakji/Searchcraft, and the author is documenting the entire process on their blog, which you can find linked in the project description. So what does Searchcraft actually do right now? The current release, version 0.1.0, includes 4 core components. First, a document loader that reads and parses text files. Second, a tokenizer that splits text into individual words or tokens. Third, an inverted index, which is the heart of any search engine. An inverted index maps each word to the documents that contain it, essentially creating a giant lookup table. And fourth, a basic keyword search function that queries that index and returns matching documents. There is also a command line interface so you can build the index and run searches directly from your terminal. It is a minimal but complete pipeline. Let me explain why the inverted index is such a big deal. In a regular database, if you want to find documents containing a specific word, you have to scan through every single document one by one. That gets slow fast. An inverted index flips this around. It creates a mapping where each unique word points to a list of all the documents that contain it. So when you search for the word Python, the engine does not scan documents. It looks up Python in the index and instantly gets back the list of matching documents. This is the single most important data structure in search engine design, and building it from scratch in Python gives you a deep intuition for how tools like Elasticsearch actually work under the hood. The roadmap for Searchcraft is ambitious and covers nearly everything you would find in a real search engine. The author has plans to add posting lists, which are compressed versions of the index that speed up storage and retrieval. There is search snippet generation, so results will show you the relevant context around each matched word. Phrase search will let you find exact multi-word queries, not just individual terms. Ranking algorithms like TF-IDF and BM25 will order results by relevance, instead of just returning every document that contains your keywords. Fuzzy search will handle typos and partial matches gracefully. And eventually, a web interface to make all of this accessible through a browser. That is a lot of ground to cover in a side project. One thing that sets Searchcraft apart is the documentation. The author is not just posting code on GitHub and hoping for the best. Every design decision is explained on their personal blog, which is hosted at rajdalakji.github.io. The blog is titled sudo rm-rf/, which is a playful reference to a famous Unix command, and the tone is genuinely fun and approachable. The author describes it as a place for code, creativity, and the occasional existential crisis that comes from staring at a blinking cursor at 2 in the morning. You can actually feel the learning process in real time as each new feature is designed, implemented, and explained step by step. The community response has been encouraging. A commenter named Mr. Crankapot called it ambitious but a great project, and went above and beyond by recommending a classic book. They pointed readers toward an introduction to information retrieval by Christopher Manning and colleagues, which is available as a free PDF from Stanford University. That book covers the theory and principles behind classic search engines in depth, and it would be an excellent companion read for anyone following along with Searchcraft. Another commenter simply thanked the author for sharing the project, showing that people are genuinely interested in seeing this kind of open-source learning journey play out. Here is the real takeaway from Searchcraft. The author put it perfectly when they said that humans spend a good chunk of their lives typing words into little boxes and expecting magic to happen. Figuring out how that magic works is a worthwhile pursuit. This project is proof that you do not need to be a senior engineer or have a massive team to build something meaningful. You just need curiosity, a language like Python, and the willingness to learn by doing. Searchcraft is still in its early stages, but it already proves that building a simplified version of a complex system is one of the best ways to truly understand it. And that is a lesson that applies to every piece of technology you use every single day. If you want to follow along with Searchcraft, find the code on GitHub and design docs on the author's blog. What system should we break down next? Let me know in the comments and subscribe for more deep dives.